So welcome today to the topic on volume and surface area of a conical frustum. And in this question we are going to find the volume and the surface area of a conical frustum. So be in touch as we progress and follow the step one by one. So the figure below shows a frustum which was cut from a cone. The base radius is 42 centimeter. The base radius is 42 centimeter and the top radius is 35 centimeter. Determine the height of the cone from which the frustum was made. Then the other question is the volume of the frustum. And also we determine the slant height of the cone from which the frustum was made and the slant height of the cone that was cut off to make the frustum. And the last question is to determine the surface area of the frustum. Now, to begin with, this is a frustum that we have been given in this particular question, and therefore we need to find the height of the cone from which the frustum was made. So for us to be able to find the height of the cone from which the frustum was made, then we need to actually draw that part of the frustum that was cut. Then we need to be able to find the height of the frustum. Now that is the height of the cone. Now the all cone. So we need to find all of this height. Then from there we get its volume and surface area. Therefore, so the height of the cone from which the frustum was made. So we need to draw this to complete such that it will form the cone from which the frustum was made. Now, so this is the cone that was cut. This part, let me call the apex A. Therefore, that is the cone. So we need to draw that perpendicular height. So we need to get the perpendicular height of the original cone from which the frustum was made. And in this case we need to use the knowledge of similarity, similar triangles. So this is B, then you have C, then E, this is the slant height. Then let me call the height of the cone that was cut off X. So this is X, this is 40 centimeter, this is 42, and here it is 40. So to get X, the value of X, now we need to know that ratio, similarities, ratio of the bigger cone, capital R of R, to that of the smaller cone that was cut off R will be equal to the height of the bigger cone. We have all of this bigger cone, H. So this is the height of the bigger cone, H. Then we have the height of the smaller cone, small h. So capital H to small h. Height of the bigger cone over height of the smaller cone, the ratio must be equal, and also length of the slant length of the bigger cone, capital L, over slant length of the smaller cone, L, will be a constant. It's always a constant. So understanding this, now we can be able to find the value of X. Therefore, in this case, I'm going to consider this part and also this one. That's what will help me to get the height of the cone. So the ratio, that is, this is actually that 5, so that is 42 to that 5 will be equal to capital H, that is x plus 40 all over H, mean x. 42 divided by 6 by 7, that is 6 over that 5 divided by 7, that is 5, equals to x plus 40 over x. Cross multiply, I get 6x will be equal to 5 times x, 5x, then plus 5 times 40, which is 200. Therefore, subtract 5x on both sides of the equation. I'll end up getting x will be equal to 200 centimeter. Therefore, height of original cone from which the frustum was made will be x plus 40, which is 200 plus 40. We end up getting 240 centimeter. That's a capital H. That is the height of the cone from which the frustum was made. Then from there we move on and we look at the volume of the frustum. Volume of the frustum. Now we need to find the volume of the frustum. For us to get the volume of the frustum, will be volume of frustum will be given by the volume of the bigger cone, volume of bigger cone, minus volume of smaller cone. For the bigger cone, that's a third pi r squared h minus smaller cone, a third pi using small r to represent the radius times small h. That is the height of the smaller cone. So we end up getting a third times 22 over 7, which is a pi. Capital R is 42, so that's 42 squared times capital H, that is there for the bigger cone, which is 240, as we got from the previous calculation. Then minus a third times 22 over 7, small r is 35 squared times height of the smaller cone, which was cut off, that is 200. Then a third times 22 over 7 times 42 squared times 240. By using a calculator, you should be able to get 443,520. Then minus a third times 22 over 7 times 35 squared times 200. Using a calculator, you end up getting 256,666.67. Therefore, if you subtract, you end up getting 186,853.33 centimeter cube or cubic centimeter. So this is the volume of the frustum. Then the next part is to find the slant height. So the slant height of the cone from which the frustum was made, and the slant height of the cone that was cut off to make the frustum. Still, in this case, we needed to use the knowledge of Pythagoras theorem, and in that case we need to come up with a right-angled triangle. This is a right-angled triangle. So this is the O, B, then from here C, let me call this is E, let me call this P. Therefore this is 42, 40, I mean this is 35, then right, this here it is 200, that is 40. Now to get the slant height of the cone from which the frustum was made, now that means it's the all length. This is the length that we need to find. So since here it is at right angled and it's right angled, we are going to use this triangle to get the slant length. So that we call it capital L. So L will be equal to the square root of 200 plus 40, that is 240 squared plus 42 squared. So in this case we end up getting, if 240 squared plus 42 squared, we end up getting 59,364. Using a calculator, we get 243.6 centimeter. So this is the length, or the slant length, from which the frustum was made. Also, we need to get the slant height of the cone that was cut off to make the frustum. Now we need to consider this part, the top part. The top part we need to consider. So we now consider and use small l, slant length of the smaller cone, which will be given by L will be equal to square root of, that will be the square root of 200 squared plus 35 squared. So we end up getting 41,225, but everything under the square root. So we get 203.0 centimeter. So that is the slant length. Now, the last part we need to look at is the surface area of the frustum. And since this is a solid frustum, then we have to include the top circular part, the bottom circular part, and the curved surface. So for us to get, we need to find the surface area of the frustum will be given by, that is area of top plus area of bottom plus the curved surface area. So area of top will be given by pi r. Since it's circular in shape, we use small r to represent the smaller radius of the top. Pi r squared plus area of bottom pi capital R squared, then plus, now curved surface area of a cone. Since the surface area, curved surface of a cone is given by pi RL, but in this case we need to find the curved surface area of the bigger cone, which would be pi RL minus the curved surface area of the smaller cone, which was cut off, which is pi RL. I've used small letters to represent the smaller cone, and here capital letters R and L to represent the bigger cone. Therefore, substituting through this formula, get 22/7 times small r, that is the top circular part, is 35 squared, then plus 22/7 times capital R, that is 42 squared, then plus you have 22/7 times 42 times, we from the previous we were able to get capital L 243.6, so this 243.6 minus 22/7 times 35 times 2, or 3.0. Therefore, we end up getting 22/7 times 35 squared, that is 3850, then plus 22/7 times 42 squared, we get 5544, then plus the other one will be 22/7 times 42 times 243.6, we get 32,155.2 minus then 22/7 times 35 times 203, end up getting 22,330. Then we add 3850 plus 5554, we get 9394, then plus we have 32,155.2 minus 22,330, we get 9825.2. If we add, we end up getting 19,219.2. This is centimeter squared, since we are looking for the surface area of a frustum. So I hope you have followed up very well, and thank you so much for watching. I'm Mr. Musyoki. Remember to like, comment and subscribe to my channel for more videos. So thank you so much. See you next time. Thank you.